Hello everyone, welcome to my channel Mathsadda. Thank you for liking my videos. In the last class we did logarithmic equation and today we are going to do logarithmic inequalities. So let's start. In this topic we will learn to solve logarithmic inequality. Before this we have seen inequality in many places now. Inequality, modulus inequality, exponential inequality, and now we are going to do inequality in log. So before we move to theory of logarithmic inequality, we first see log of half base 2, log of 1 base 2, log of 2 base 2, log of 4 base 2. Can you arrange them in ascending order? Log of half base 2, this is minus 1, this is 0, this is 1, this is 2. So this means log 4 is greater than log 2. So what we see, if term is higher, if term is larger, log term is also larger. See, 1 is smaller than 2, so log 1 is smaller than log 2. Or I can say if log is less, number is less. So what can I say in general? Log of x base 2 is less than log of y base 2 implies x is less than y. Take one more situation. These four terms, now if you want to arrange in ascending order, this value is 1, this is 0, this is minus 1, and this is minus 2. Now you see this order has just reversed. Log half is greater than log 1, and log 1 is greater than log 2, and log 2 greater than log 4. So how come? It's just opposite. It's smaller number but log value is larger. So what we see, log of x base half is greater than log of y base half implies x is less than y. So you see this first one and you see this second one, you just see two opposite things. What is here we are missing? We are missing this base. When base is more than 1, it looks like you remove log, here log x less than log y, remove log, x is less than y. When you see base is half, that is less than 1, log x greater than log y, when you remove log it just becomes opposite, log x is less than y. So let us write this. Log x greater than log y, it implies x is greater than y when a is greater than 1, and same thing implies just opposite, x is less than y when a is between 0 to 1. This is the key formula for logarithmic inequality. So we will be solving all the logarithmic inequality questions using this formula. So this is very important, and I can tell you this is the only formula of logarithmic inequality which will be able to solve all the questions. Before we move ahead, we must know few things about solving equations or inequality. So I am writing few important points here before we solve logarithmic inequality questions. First one is, when you solve equation or inequality, it is must that equation or inequality be defined. If it is not defined, there is no point in solving it. Some precautions. Squaring of an equation may lead to addition of roots. Let us take an example. 2x is equal to 4. If you square it, it is 4x square equal to 16. X square is equal to 4. X is equal to plus minus 2. This is when you square. Without squaring, when you solve, x is equal to 2. So this is the real situation. When you squared it, you see minus 2 comes here. So this means when you square a equation or inequality, you must ensure that something new is not added. Next point, cancellation of terms may lead to loss of roots also. Let's take an example. X into x minus 1 equal to 2x square minus 3x. So two methods, let me solve it. First is x into x minus 1 is equal to, take x common because I see 2x square minus 3x, it becomes 2x minus 3 after taking x out. Now if you cancel it, x minus 1 is equal to 2x minus 3 implies x is equal to 2. Another method, this is what, when you cancel factor, right? You see here, you cancel factor. Now this way, another method, x into x minus 1 is equal to x into 2x minus 3. Bring everything one side, x into x minus 1 minus x into 2x minus 3 equal to 0. Take x common, x minus 1 minus 2x plus 3 equal to 0. X into minus x plus 2 equal to 0. X is equal to 0 or 2. You see, you get one more answer here. You missed that answer here. Put 0, 0 will satisfy this equation. So correct situation is 0 and 2, both are answers, but here you see only 2 is answer. So when you cancel factors, there can be a situation where you actually lose some roots. So please be careful while cancelling factors. Next point, it is about log. When base is not given, you consider base is 10. So if it is log of 3 and here base is not given, nothing, so you write log of 3 base 10. Now let's take first example of logarithmic inequality. Log of x base 2 greater than 3. This is easy question. We will be solving this using two methods. First is log of x base 3 greater than log of x base 2 greater than 3. What we can do, convert this logarithmic information to exponential. How can we do that? X is greater than 2 to the power 3. So you convert this to exponential and keep the sign same, greater than. This is when base is more than 1. So if I take just example log of x base 1 by 2 greater than 3, then what I will be doing, x is less than 1 by 2 to the power 3. So you convert to exponential but change the sign when base is there. So this is one method. I prefer second method. What we do here, log of x base 2 greater than 3. You see, log inequality, both sides is log here. Then you apply this formula, both side log, same base, you remove, you write x greater than y. We want to apply same thing here. So right hand side there must be some log term. I see only 3 here. So convert to log term. Log of x base 2 greater than, this is 3 into log of 2 base 2 means 1. Now both side base same, so we can now I apply that formula. Log of x base 2 greater than log of 8 base 2. Since both side log term, now remove this one. Don't do like that, you think like that, x is greater than 8. That's your answer. Before we move ahead, let's see some more situation. If we see this type of inequality, log of fx base a greater than log of gx base a, how to solve it? So first thing is we must see what is base. So I divide two situations. When a is greater than 1. When a is greater than 1, what you do? Just remove these log terms, right? And then fx is greater than gx. Fx is greater than gx. One more thing is fx must be positive so that log is defined. I told you if you're solving equation or inequality, those terms must be defined, that inequality or equation must be defined. So fx should be positive, तो fx is positive. ऐसे ही gx क्या होना चाहिए, gx must be positive, so gx must be positive. All this together, what can we say? fx is greater than gx, but I see gx is greater than 0. So can I say all together it is fx greater than gx greater than 0. See, this one satisfies all three, this one as well as this one as well as this one, right? So this means when base is more than 1, this inequality simplifies to this one, right? So if I want to solve here, I will actually solve here, right, which does not contain any log term. It becomes algebraic inequality, which we can solve using sign scheme. Now second situation, when a is between 0 and 1, when a is between 0 to 1. So if base is between 0 to 1, so log fx greater than log gx, what will happen if you remove log? If you remove log, it will become fx less than gx. So fx less than gx, sign changed. And what is the additional thing? Fx must be positive, gx must be positive. So fx greater than 0, gx greater than 0. This together, it is fx less than gx and fx more than 0. This is which will satisfy all three inequalities. So if I want to solve this, better I will solve this, which can be done using sign scheme. So let's take one example to see how this theory works. I want to solve this inequality, log of 3x minus 1 base 1 by 4 is greater than 0. So what I will do, I will be writing this one as log of 1 base 1 by 4. Now since I see base is 1 by 4, remove log. Don't do like this one, you think like that, I say again and again. Remove log 3x minus 1, this sign will change. So it will become 3x minus 1 less than 1. And then this term, this is log b, right? This should be positive, so this must be greater than 0. Now you are supposed to solve this one, which we can do very easily. So bring 1 this side, it becomes 1, 3x, this is 2, and x is from 1 by 3 to 1 by 2. This is your answer. This was easy question, so it was done easily. Now let us see, can we do next inequality. This is log of x square minus x minus 2 base 0.2 is greater than log of minus x square plus 2x plus 3 base 0.2. How to solve it? I see here base is less than 1. So what will happen? X square minus x minus 2. Sign will change. Be careful. Minus x square plus 2x plus 3. Now both the terms would be positive, so that log is defined. So put here this now both are positive, so this is equivalent to solving this logarithmic inequality. I hope you guys are able to connect what I am saying. Now how to solve this inequality? This inequality you can break into two parts, one this inequality and other this inequality. So I can say x square minus x minus 2 should be greater than 0, as well as x square minus x minus should be less than minus x square plus 2x plus 3. Clear? So let us solve this first. And I am saying this and this, so you should not forget this one. So whatever answer you get here and answer you get here, it must be common, which will be considered as final answer. So solve this part. So it is 0 is less than x square minus x minus 2. So can we factorize it? Yes, it is sign scheme question. It is x minus 2 into x plus 1. Critical point 2, critical point minus 1. So number line. minus 1 to highest power x square. It's positive, so we start with positive, negative, positive. We are looking for greater than 0. See that this is greater than 0, so positive, positive. Now this means what? Minus infinity to minus 1 union to infinity. Now second part is here, x square minus x minus 2 less than minus x square plus 2x plus 3. Bring everything one side, it is 2x square minus 3x minus 5 less than 0. Once you factorize, it becomes 2x minus 5 into x plus 1 less than 0. See here, from this step to this step you will have to do some calculation. Do that by yourself by splitting the middle term. Now what is the critical point? Critical point is 5 by 2 and here minus 1. Plot number line minus 1 and 5 by 2. You are it is positive, negative, positive. You are looking for less than 0, so this is minus 1 to 5 by 2. Remember what did I tell you? This and means common answer. For common answer we take intersection. For that we plot number line, and then this is first answer, minus infinity to minus 1 to infinity. Second answer is from minus 1 to 5 by 2. This is common region, 2 to 5 by 2. So 2 to 5 by 2 is final answer of this inequality. I hope you have copied all the steps. If not, please pause and write all the steps, try to connect and see the logic behind this method. So this will be our last question for today's class. Log of 2 minus x base 1 by 9 is greater than log of 2 by x minus 1 base 1 by 9. So what is the condition? First let us see base. Base is 1 by 9. So if you remove log, sign will change. So 2 minus x would be less than 2 by 1 minus x. Now, and this would be greater than 0, right? So that log is defined. Now solve this first part. This is 0 is less than 2 minus x, so it is x is less than 2. So it is minus infinity to 2. Second part we will have to solve this. Do it here. 2 minus x less than 2 by 1 minus x. You cannot cross multiply. You remember I told you in sign scheme, in inequalities you cannot cross multiply. What you need to do, bring all the term to one side. You must remember everything what you learn. So you must 2 minus x less than 2 by 1 minus x. You must bring all the term to one side. It is 2 plus x square minus x plus 2 by 1 minus x less than 0. It is minus here. So this 2 will cancel out. It is x into x minus 1 by 1 minus x less than 0. You are not supposed to cancel it. I told you earlier. Don't cancel factors. Now critical point 0 and 1. 0, 1. 1 I see 1 power here and 1 power over here, right? At critical point 1. So it will be star. Now I see highest power. It is x square by minus x negative. So it starts with negative. It starts, so don't change sign, negative, and this become positive. We are looking for negative. So this one and this one. 0 to 1 union 1 to infinity. And what we need to do? We need to do intersection. So do intersection. For that we plot number line. First is minus infinity to 2. minus infinity to 2. Other is 0 to 1, and then 1 to infinity, skipping 0. So I see common part is 0 to 1 and 1 to 2. So final answer is 0 to 1 union 1 to 2. This is answer for this logarithmic inequality. I hope you guys are able to connect with theory of logarithmic inequality. I think this is a bit heavy, so you must see this video 2 times so that things are clear. So I will stop this class here only, and in the next class we will be doing practice on logarithmic equations and inequalities. In the end, I have added some questions for practice. So thank you everyone for watching this video. If you like this video, please like it, share it, comment on the comment section and subscribe it. Thank you.